Hey, what's up guys, my name is Cherno and welcome to the 9th episode of the Serialization series. So, last time we talked about fields and we implemented this field class, which more or less just writes out a bunch of data, okay? And we had all these, we had these subclasses of field that basically just made our lives easier. They didn't really do anything, like there's no reason this should really be a subclass apart from the fact that it just kind of sets some default properties. Like, you could easily just implement this as a static kind of class, like as in you could do something like public static field create int or just int, and then you could take in that same name, right? String name was an int value, and then you could just kind of copy and paste this, over here, and you would get the same result, right? This would do exactly the same thing. Well, you know, if I kind of actually properly do this, and it would look something like this, and it would do the same thing, right? It's up to you what you want to do. There's no penalty in creating it as a subclass. I think it just looks a bit cleaner. Again, API wise, it doesn't even matter. Like, it will kind of still look the same, I think. Like, that will, yeah. I mean, it's up to you what you want to do, right? It actually might make more sense. I think I might just do it this way right now. I'm making this decision as I go along, by the way, because it means that I don't have to create 1,000 classes, and that will take time, and they all have to be in one file, which is very annoying. So let's do that, actually. Let's just do it. Create int. Now I'm just going to call it like that. All right, so we've got integer. I mean, we might as well go through this now and quickly implement all the other ones. I'll put these at the very bottom. So we've got integer, we'll do byte. We'll sort these in order of size, I guess. So byte, and we'll do short and char and integer and long. All right, let's kind of go through these and fix them up real quick. So this will now take in a byte. What was it? Byte. Yes. What else needs changing? I think that's about it. Yeah. So the only thing we need to change is the types, and everything should sort itself out properly. Note, you can see that even if we're writing a single byte, we still kind of store it in an array. That kind of just means that we don't have a special case or anything for it. Everything is kind of consistent, which is good. All right. Int and long. And finally, well, we've got 3 more, don't we? Float, double, and boolean. Okay, so where do we stop? Float. Double. And boolean. All right, done. So here we have everything. Actually, do we even have a? I guess we do, right? Right, bytes boolean. Yeah, we do. Fantastic. Okay, so we've got all that going on. So now, yes, we can create it just by typing like field.integer, and there's our integer. Let's try it out with something like a long, just for fun. We'll set this to like 10 or something. One thing I do want to quickly add that I was thinking about while I was editing the previous episode, which is actually currently uploading. That's how much I'm just gonna slap all of these out. I don't know why I chose the word slap there. I'm gonna just bang all of these out, and and get this series over and done with, honestly. Anyway, so what I was thinking about last episode was we really should have a way to get the size of a field, for obvious reasons, but if we literally just have like a get size, I'm sure that wouldn't be too difficult to calculate, right? All we know is we've basically can just return 1 plus 2 for the name length, right? If you really wanted to be precise, like, I mean, it depends how you want to write this. You could be really, like, really kind of, what's the word I'm looking for? Really anal about this and just actually, you know, do something like that. That's going to take a lot of space up, and like personally, I don't care for stuff like that, especially if we're doing it in Java and we know the size of each type. So I'm just going to write it like that. Feel free to write it properly. Again, this is, yeah, I'm not going to. Okay, so we need to get the name length. So remember, the name length in bytes is just going to be name.length. Then the type, and then finally the data.length. All right, and that we should have everything there. Okay. So one of the things that I think I forgot to mention last episode was the fact that, and I'm not sure, again, I'm just uploading the episode 8 now, so I don't know if you guys noticed this, but you might be thinking, why is there no size given for the amount of bytes in here? Well, obviously because the type, you know, tells us what data is in here. So the type tells us the size of this byte array. For example, if the type is set to int, we know that there are 4 bytes here. They have to be, okay? Unless it's, well, they don't have to be, obviously. Things could happen. Someone could go and modify the file and break something. But as far as we know as the reader, as in like, well, when we're reading this data back, we know that if we see a type of integer, we need to read the next 4 bytes, okay? Obviously, there will be safety checks and all of that in the reader just to make sure that it's correct. And if so, and if not, it'll just mark the file as invalid. But as far as we know right now, that's basically what it is, right? So data.length basically, and we could do a bunch of things here to assert it, right? We could do something like asserting the fact that data.length has to equal type.getSize type, or rather just type, right? This has to be true. If it's not, there's a problem, okay? So that's, you know, there are certain things we could do just to make sure that we're kind of correct, and that we don't ruin everything. I might leave these in here, I might not. The reason I want to leave it in here is because the data can get set at any time. Like, for example, there is no, like, the field constructor right now, which doesn't actually exist. You know, we only kind of finalize the data here. So we could be running some kind of integrity check to make sure that everything is correct. Again, I'm not going to go ahead and set up anything like unit testing, but just something to think about, right? If you're actually developing this, and like, I would be asserting pretty much everything, okay? I'm not 100% sure how these work in Java. I mean, I could literally just Google it right now, but no, I'm not gonna do that. But yeah, I mean, like, it's always a good idea to kind of just write asserts everywhere where there is something that is kind of sensitive, right? Which is like, this stuff does rely on everything being correctly aligned, like especially when reading this, okay? And then what you can do is you can generally keep track of like a boolean, which is something like invalid, and anytime something is a little bit off, well, not a little bit off, but something is definitely incorrect, you just get out of there, right? And that's particularly important because, again, since we're dealing with kind of raw byte arrays, a lot could go wrong, right? Well, I mean, really the only thing could go wrong is underflowing and overflowing, particularly in Java, overflowing. So yeah, you really need to think about that. Okay, cool. For example, I have to say, one of the things that I haven't mentioned is that every single one of these functions right now could absolutely cause an array index out of bounds exception. Yeah, I mean, it's clearly going to happen, right? If you pass in a byte array here that has a size 7, well, guess what? This line right here is going to end up with an array index out of bounds exception. It's going to happen, right? And I don't really want to surround it. Like, it's very easy to check. Yeah, you could definitely just say, something like if destination, or you could, in fact, we could write asserts pretty much everywhere. Writing something as simple as if destination.length is, or asserting the fact that destination.length is greater than pointer plus, what is it, like 8 in this case, right? Or type.getSize type.long, right? If we assert something like that, that will just kind of make sure that we're actually not going to overflow. In fact, that's probably not a bad idea. I might leave it in here for long. In fact, you know, since we're on a good trend of writing quality software, let's what is it, just int? Let's just put this everywhere. But you kind of get what I'm saying, right? We kind of need to make sure that we're not going to write over protected, or writing over memory that we shouldn't be writing. And well, in this case, yeah, crashing is probably the better term. Okay, reading is fine. So yeah, write string. I mean, that just results in more write byte calls, so that's fine. This will be a boolean. Let's see. Double float long int char. This time I am using getSize. Yeah, I think it makes the code a bit more readable as well. And if we really wanted to as well, byte. And in this case, we could just assert it with source.length. All right, cool. So there we go. We've got some nice kind of assertions here just to make sure that everything's going well, which is always good to do. Especially because the idea with assertions are that really, like, they don't exist in release builds. Again, I actually just don't know how that works in Java. I wish I did. I should really do some research on this. But the way that assertions typically work is there's something that you kind of keep active in debug builds, and you don't keep them active in release builds or distribution builds. So what that means is that when you're kind of just testing this code and you're kind of running it in quote-unquote debug mode, what happens is these assertions are on, which means that when it enters this write bytes thing, it will verify it to make sure that this Boolean statement is true. If it is true, it will continue on to the next line. If it is false, it will break, like the compiler will, or sorry, the IDE will, the debugger, that's the word I'm looking for, the debugger will break on that line and let you know that that assertion is false. And then you can be like, okay, I've got a stack trace and I've got everything I need to sort out why this happened, okay? But on release mode, assertions just kind of get removed, right? They're gone. So they don't affect performance or anything like that where it matters. They only affect performance when you're kind of debugging, which is important. So that's kind of how that whole thing works in case you weren't really familiar with what assert actually does. Again, I really should read up about it, about how it works in Java, but I imagine that it's exactly the same as it would in any other language. Okay, cool. So now the purpose of why I did that is we can actually just do something like field.getSize now. Okay, we don't have to kind of create that massive thing. So if we do print out a long here, and something is erroring me, I'm not sure exactly what it is. Okay, yeah, that's right, I got rid of it, field. Okay, good. So that's good. Yeah, so it looks like our size is correct here. Again, I'm not going to go through all these bytes, but we know that the first thing means it's the field. The next short means that's the length of this thing. So if I change this, well, yeah, I'm not going to change this. You guys believe me. The next 4 bytes are the actual test characters. This 5, I believe, is the type of data. Yeah, so long as type is 5, I believe. Yeah, here it is, 5. And then the next 8 bytes are that actual long. So you can see it ends in A, which is 10. Okay, cool. So there we have it. That is how the field works. So I've just refactored it and kind of got it to work right. So the main thing that we're kind of going to move on to this video is talking about, and I hope these videos aren't getting too long. I always don't know what to do with videos because, like, I have it in my head that people really only watch 10 to 20 minute videos tops. and that if I put out a 30-minute video, people have to kind of be like, oh man, I really have to make a commitment, or they bookmark it and return to it later. I really don't know what to do with videos and lengths. So like, I mean, I could break this video up. Like, it's 15 minutes right now. I could say that's it. I could wrap up this episode and I could continue what I was going to do this episode, basically next episode. But then I end up with a lot of videos, which is kind of a good thing. But also I feel that people don't watch that because there are too many videos. I don't know what to do, man. This whole YouTube thing is difficult. But anyway, I want to just continue this episode. So, and then you guys can let me know what you think in the comments. Your assistance will be greatly appreciated in this matter. Okay, cool. So we're going to move on to our kind of next container type, I guess, and that's going to be an array. So arrays are very similar to fields. Arrays are literally, I'm talking about literally just flat arrays of a single data type. Flat as in the fact that it's just continuous memory or contiguous memory. We're going to just call this array. I'm going to take a lot of things from field, I think. We could probably take the whole thing, really. Let's just take these things to begin with. Again, they are going to be laid out as if they were a field. Container type is going to be set to array. They're going to have a name. The only thing that is different is they're going to have a type, and then they're going to have an int, which is element type. Sorry, what am I doing? Count. I'll just call it count. So this is element type, this is element count. I've made it an integer because, again, like we could be storing a lot of elements. In this case, with a signed integer, we could be storing 2 billion. So 2 billion is probably enough, right? I don't think 60 or 32,000 is enough. Like, yeah, an integer is probably a good choice here. And if you always need to have above 2 billion elements, which is probably very rare because that is a lot of data, you could always split it up into multiple arrays. Okay, so, and then we have the byte data. So that's it. We're just adding this field here. Could I just extend field into array? Yes, of course I could, but I'm not going to. All right, so set name, we're going to steal. Yeah, you guys can kind of see how I'm going to end up reusing code. I might make interfaces, or I might make a general subclass called like container, and then that will have certain things like set name and get bytes and stuff, because every container is going to have a name. We're going to talk about actually laying this API out probably a bit later. I'm just going to implement it right now, and that will be fine. So we'll grab set name, we'll grab get bytes. Again, these are going to be implemented slightly differently. This is going to be exactly the same. But this stuff, again, let's just grab one of them, right? So when we create this, one thing I really should do is make the constructor private, right? Because the only like class really that's supposed to be constructing field is field. Okay, when we call these static methods. If we just make a new field like that, that really shouldn't be a thing, right? That's not my intention. All of these are public, so you can always modify them before you actually do hit get bytes, but constructing a new field like that doesn't really make sense most of the time, unless you are going to overwrite everything. So starting off with the default template, which is basically what this is gonna be, I think it's gonna be the best. All right, so we've got this. So this is going to return an array. I should maybe prefix all these with stuff like RC array, rain cloud array, because I'm thinking that this might be annoying if these start conflicting with Java types. I mean, if we start making class like, I mean, is an array actually a Java type? I bet it is. It's Java reflect. So it's only a reflection thing. As long as it's not in .lang, I think I'm safe, right? As long as we don't start making stuff like integer, we'll be fine. Okay, so array equals new array. So we're going to be taking a name and an array of something. So let's start off with our typical example, integers. We'll call this just data, I guess, because the other ones were called value, right? Yeah. So value versus data. All right. So data. So we'll array set name, type is going to be integer. Data is going to be int. Why is that called int? It's going to be called integer from now on. I don't like to skimp out on some names. Okay, so we're going to write bytes into array.data, and we're going to be writing that in. We haven't done that yet. All right, fantastic. It's time to do it. So this is going to be fun. So we could just, I guess we could just, the easiest way or the simplest way in terms of writing code for this would probably just be to call that. So if we do something like write bytes or pointer equals write bytes into destination pointer and source I, right? Again, that is a lot of function calls. Ideally, you probably wouldn't do something like this unless this was like an inline function, but it's okay. Well, I mean, like I keep bringing these things up as I implement the rest of these. I'll have a little bit of a chat to you guys. As I keep bringing all of these things up in terms of like performance and stuff, and I keep talking about optimization, you know, like, I mean, we're using Java. Like, there are some things we could do in terms of optimization, but there's not a lot, honestly. If this was C++ or C or something like that, we would be probably spending more time thinking about how we can make this faster. But for now, I've got two things in mind. A, I want to get this totally implemented. This could totally be a generic function, by the way. It has to be, right? Let's try write a generic function in Java. How do you even do that? I actually don't know. All right, Java generics. Sorry, it's been way too long since I've done that. Can I have some examples, please? This is funny. I hope you guys don't mind the kind of unprofessional thing that I'm doing right now. I like to think this channel is a human channel. Okay, so it looks like you put the thing here just before the return type. That's a bit weird. Okay. T. All right. So then that has to be T. See, that's where it's going to be unfortunate. I'm not sure if we could genericize this, because there's no real way to just get the bytes of any type, are there? Not really. Yeah, it's a bit annoying, isn't it? Because that now needs to... See, if this was a template, then this wouldn't be a problem, because it would just, it wouldn't compile if there was no write bytes that took in one of the usages of T. It's just that here it has to actually be truly generic. Not kind of like a template where it actually doesn't really have to. All right, anyway, if anyone knows in the comments how to do this, tell me, and we'll rewrite this as a generic thing. But if there's no elegant way to do it, which I suppose there's not, then I guess we'll deal with what we have. Because the thing that I'm thinking of is the fact that, like, you know, these are all specializations of that generic type that we can't implement. If that was a T thing, we wouldn't know how many bytes, we have to work out how many bytes it took up, which we couldn't do either. And we'd have to, I'm not sure. Anyway, it would get complicated really fast. It just did, actually. All right. So, we're almost done. Boolean value, it's the last one. This serialization stuff though, seriously. All right, done. And the only thing I'm changing is the type as well, because obviously it's going to, as you can see, use the write bytes. Here. All right, done. So we can now write arrays. So that's all we have to do now. And then we just return the array and we're done. So now we add 1,000 of these. So we've got one for int short char. Oh, sorry, byte short char. Byte short char. Byte short. Oops, we have to make sure that we do indeed. Oh, this is important, isn't it? Because that's going to be wrong. So this has to be type Okay, so now we probably... Okay, this is good. I was going to say there's something missing here, and there is. We could obviously just do something like... Also, we're not even setting the count anywhere. We need to set the count to be data.length. Okay, we could just kind of multiply this with the array.count, copy everything in there like we did, and everything will be the best. That's okay, but again, it is an issue because it means that you actually have to copy all of the data. Now pretend this is an array with 1 million elements in it, right? Copying every single one of those million bytes into another array, right? First of all, that's a huge waste of space. I mean, 1 million bytes is only a megabyte, but still, that's a lot of just space to just allocate, and it's not even about the memory usage. It really isn't, because a megabyte, I mean, even though that is actually a considerable amount of memory, that still isn't anything that we can't handle. It's the performance that comes with it, right? Allocating, first of all, that much continuous memory or contiguous memory is a chore, but also there's the copying every single element. Like it's actually a problem. It'll be a measurable thing. So what we want to do instead is simply reference it. How do you reference it? Well, glad you asked. It's actually really easy. All we have to do is just set array.data equals data and not worry about the writing bytes. So it actually becomes easier. The issue is that if that data gets garbage collected for whatever reason, this reference dies, right? I don't think it will get removed. I'm trying to think about it. I actually think that in Java, as long as the garbage collector sees that we're still holding on to that reference, it won't delete the memory. It won't free the memory. So in fact, this should work. Again, my lack of knowing Java very well apparently is coming through again. But yeah. As far as I know, I don't think the garbage collector really is allowed to just say, okay, we're done. Again, this would be something that is a lot more problematic. We can't do that here, obviously. That is something that would be a lot more problematic if we were actually using something like C++, and then someone actually does delete the data, because of course it is in that like situation possible to free memory that is still being used somewhere, and then we would be really screwed, because when we actually write this data out, then we reach for it and it's not there. Okay, this is another thing that we have to think about. We've got this short array of data that we really need to convert into a byte array. So let's see if there's a way that we can actually type. So after a bit of Googling, this actually seems to be a problem, because no one, as far as I can tell, actually has a good solution for this. Looks like bytebuffer.wrap might be something that we can use though. What does that do? Wraps a byte array into a buffer. Yeah, that's not what we want. All right, so this is not good. So there doesn't seem to be a way to do this. Every single thing that I've read so far, and I spent about 10 minutes, like it's been a while, have suggested actually copying the data, which is unacceptable. So here's what we're gonna do. We're actually going to make a bunch of arrays. Okay, we're gonna make a short array. So short data. We're gonna make, you guys can kind of see where this is going. We're going to make one for each type. Okay, and then according to the type, we're going to set the appropriate array, and then according to, of course, which type is set here, we will write that data out. Now, would I do this? Like, is this it's not the best solution, but it looks like it's the only solution, since we actually can't get past Java's type system. As far as I can tell, right? I don't know everything about Java, so I can't tell you for sure if there's a better way to do what I'm doing. Obviously, if there would be, I would be doing it. So feel free to use your excellent Java knowledge to write a better solution. But I can't think of one right now. So we're gonna, and this is gonna work fine. Like there's no issue with this. This will perform exactly the way that we want it to. The only issue, I like that kind of shape there. Anyway, the only issue with this is it looks a little bit messy. But in terms of like performance and how it's actually gonna work, it's gonna be beautiful. All right, so, and that's all I really care about. Okay, so in case you didn't catch on, instead of setting data here, we actually are going to set short data, all right? And then kind of so on and so forth, right? So again, we are setting references. That's not what we're doing. We're not copying data. Copying data would be something like this, okay? This is actually setting a reference. So no data is being copied. We're simply setting the pointer to this data. We're assigning that to this pointer here, okay? And remember, this is an array, so it is literally just a pointer to a block of memory which contains the actual elements, okay? So it's not like a bunch of elements here. They're not, yeah, this is just an address that contains the actual shorts, okay? All right, awesome. So we'll continue this. Char, we'll do char. I don't need to do that. So this will be char data. Let's just copy this because I don't really want to. I guess all we really need to copy is that. Oh, that's it. I didn't make more. All right, sure. Int data. So we still need long, float, double, and boolean. So long, float, This is lovely. What's wrong with you? Oh, right. Okay. I wish this one would come up as it. Anyway, doesn't matter. Oh, we need to change the names of all these as well. Forgot. I've been forgetting to do that. So this is double, and this is boolean. Whoops. Boolean. Okay. Boolean. All right, so let's change the names quickly. So this would be byte. That's actually the only correct one. Short. Char. Integer. Long. Float. We don't really need to. We could just, I guess we could just make create and then pass an appropriate type of data. But I kind of just like, I think when reading the code, it would be a lot easier to see this. And also it means you would make less mistakes. For example, not really less mistakes, but if you accidentally change a type, for example, you really wouldn't know if you did because there are so many overloaded functions. Whereas if you do here, you're gonna have to actually change your code to reflect that. Again, you may or may not want that. It's up to you, but I do. I think I want to be more specific with my types. This is a strongly typed language anyway. So there we go. Right, that should be everything. Let's test this out. Oh, well, of course, we forgot this. So this is the actual data that we're writing out. So that's going to depend on the type. So if the type is, did I do a case statement here? Yeah, I just realized I did that in like C++ style. All right, there we go. Yeah, that just came back to me. All right, so if the type is set to byte, then we simply, like there's gonna be a lot of this here. We simply do that. All right. Otherwise, if type is set to, I guess we'll begin with the top, which is like short. If they are really sorted by type, I guess boolean should be up there with byte. But anyway. All right. So short, char, integer, long, float, double, boolean. And the only thing that changes, of course, is that we write out short data instead of the other thing. And char data, and int data, and long data, and float data, and double data, and boolean data, and that should be it. All right, so let's test this out. Back in main, let's make an array. I'm going to start off with bytes first. Array is going to be, I'll call this data. We're going to say 1, 2, 3, 4, 5. We're going to have array. I guess we'll have, let's just import that, our one. I guess we'll do get size as well. We don't have that, do we? Nope. Public int get size, return 1 plus 2 plus name.length plus type, oops, plus 1, count is 4, right? Yep. Okay, and then this is going to be difficult because getting that size depends on what it actually is, which is fun. So, public int get array size, or get data size, we'll call it. So in comes the thing. Again, this is the type of thing that you could have avoided if Java was either a better language, or if I was a better Java programmer, depending on whether or not it's actually possible. Anyway, this is going to be easy though. So this is going to be return, in this case, yeah, data.length. I guess we'll do ×1, or times type get size type.byte. Let's copy and paste that a bunch of times. Return 0. Okay, so again, this, as you can imagine, changes to short data, char data, and int data, and long data, and float data, and tuple data. This is, yeah, heaps of fun, this serialization series. It's actual work is what it is. No fun, just work. It's still fun. I still enjoy this, don't you worry. Otherwise I wouldn't be doing it, right? Right. Okay, so there we have it. So now we can just do plus get data size, which will give us the exact size in bytes. So, yes, that's good. All right, cool. Let's test it out. So, array, log, byte, of course. We'll call it test. We'll set the data to data. I mean, we don't need to, yeah, so I'll call this elements. The data, of course, will be array.getSize, and then we'll actually serialize this out. So I think I'll call this my stream, actually. Array get bytes, just because that makes more sense than data. I think, like, if anything, this should be called data, because it's actually the data that we're doing. So let's see what this does, if not crash. Okay, cool. So that's a little bit odd, I think. Is it? All right, let's go through this. So type 2, right? Or container type 2, which is array. Then we've got the short, which is the type of data that's in there, right? No, what is it? Oh, name length, sorry, 4, test. Then we've got the type, which is 1, which is a byte, that's correct. Then we've got the count. No, we don't. That looks like the actual, oh wait, obviously, I'm still not printing out anything. So we've got name, we've got name length name, then we've got type, then we need to have count. So we need to print out count. This is why we test. And then we, of course, print out what we need to do, and then at the end we don't print anything. So really, that should be correct. I just don't understand what these are. Oh, these 4 bytes at the end, right, that's right. That's because, of course, in the size calculation, I did include type, which is right here, but I didn't include it in the bytes that we wrote out. So now we should be good. Yeah, this is more like what I was expecting. So then here is that type. Sorry, here's that count. Yeah, sorry, not count, type. Sorry, not type, count. That's what I meant. Count, this variable. So there it is right here. It's 5, which is correct. And then here are the 5 elements. Let's try something a bit harder. Let's do an int array. Not really harder, but, you know, different. int array. So nothing really should change here. I'll run this again. It becomes a lot larger though. So I guess we'll kind of steal it. I guess we will. Let me just open up Sublime Text. This might be easier with Sublime Text. That is taking a while to open. All right, it's open. All good. All good in the hood. So here's the data. Let's see if we can find the beginning of it. What did we start with? 1. So I guess that's the beginning of the data. And then we'll cut in here as well. Okay. So, 2. Then we have the name length. We've got the name. We've got the type, which is 4, which is correct, integer. Then we've got a bunch of zeros. So what's that all about? That's data, is it? No, that's count, right? So count is 0. Okay, that's wrong. And then we've got the 5 things. So that's of course also wrong because I must be printing data. Yeah. Okay. So I'm still like my count. Wait, hang on a minute. So count is am I not saying that? Oh, I forgot to set that. I was gonna say, yeah, all right. Fair enough. I forgot to set that. All right, third time lucky. First, I forgot the actual count variable to write it out. I'm always neglecting count here. I guess that's because it's the only addition above field. All right, updated version. So really, the only thing that should be updated is this section here. Just become that. So there we go, 5 elements, and here they are. Let's try something a bit more fun, just to see if this can handle it. Int data equals new int 50,000. For int I equals 0, I is less than data.length, I plus plus. We'll make a static random, this new random. And we'll import that, and we'll say random.nextInt, no bounds, data I equals that, and we'll just do that. All right. Should we print it to the console? Well, let's just do it. Wow, that printed very fast. Oh no, it's still printing. Yeah, I was gonna say that. Oh wait, no, that did print fast. Okay, it's still going now, and now it's done. That's a lot of data. Wow. Okay, so there's all the data. I mean, it didn't crash, so I'm going to assume it worked. Okay, cool. So there we go. That's going to wrap up this thing. Hope you guys enjoyed this video of the serialization series. Next time, I think it's going to be episode 10. So one of the first things that I really want to do is actually make it so that we can write this out to a file as binary, so that we can view it in like a hex editor. And make sure that everything is okay there, because obviously if we do something like print 50,000 things, it's going to be a bit annoying. But also we're going to start taking a look at the most complicated container type, and that is an object. So an object is just a collection of multiple arrays and fields, and objects also have names. All right, cool. Thanks for watching, guys. Hope you enjoyed. If you did and you want to see more videos like this, then please support me on Patreon if you can and or want to. You get certain rewards like access to the kind of super secret Sparky repository, as well as all the game programming code via GitHub for just $5 a month, which is a very good deal. If I didn't have that code, and I would definitely pay that much money, to be honest, because I think it's pretty cool code. But that just helps me make more videos, and that's what I'm really trying to do this year, which is why I'm making all these serialization videos. So anyway, if you can't support me on Patreon, then that's totally okay. Just hit the like button and keep watching my videos. I'll see you guys next time. Goodbye.